And so this is a kind of a finish of the discussion around chapter 12, which is, again, a pretty big chapter by this book standard, 50 pages, 60 pages, something like that. And so it's been broken up across many days. I think we even started 3 or 4 days ago. And we just really took a lot of days to kind of hit a lot of link and dove a little deeper than the book does, I think, than in link. And now we're kind of back here talking about, the DB context class and the other operations, right? So we use link to do a bunch of reading. And of course, you have to do adds, updates, and removes. And then this DB context class. Now, this is on page 45 of this textbook. And the thing that stood out to me about this theory that the slide deck doesn't really talk about is that we're dealing with a disconnected model when we're working on the web, right? So remember, HTTP is by default, it's stateless. So it's kind of like, hey server, give me a page, and the server responds with the page, and then the client sits with that page. As always, I'll share my screen. Not that. So imagine this, right? So you're looking at a web page, right? So there's no open connection between the client and the server, right? And so you could be sitting with that page. Maybe you're editing a record, and you could be sitting with that in theory. I mean, do you click on the save button a minute later, 5 minutes later, an hour later, like the next day, 24 hours later, right? And so you're working in a disconnected model. So you have to factor that in. Let's say you're editing a customer, right? And someone else goes to edit that customer at the same time, right? So someone else is changing their last name and you're changing their street address. Well, that can cause what are called concurrency problems, right? So you're essentially running an update, and so are they. They're updating a field, again, whatever I said, their last name, and you're updating their address, and so you still have their old last name. So imagine this, they update the last name, and then you click save after that, and you update their address, but you have their old last name. So you essentially overwrite the last name back to the old last name, right? So in this disconnected world that we live in, because HTTP is stateless, you have these problems called, and I'm kind of curious the root of this word, like what is concurrency? I haven't heard it in any other context outside of this. But I've heard of, I've addressed concurrency problems on the web for a long time. And so we just learn how to deal with that here. Again, this is kind of new, and this is not something we've done before.
Yeah, I think that word is strictly used in computer science.
Is it? Okay.
Yeah.
So it's not really used outside of here. And I haven't heard outside of this context before. The book does note, and you might remember this, maybe you don't, but because of the disconnected model, like basically you have to call this save changes. I would draw your attention to this method right here, the edit method. Going back to passing by reference and passing by value, when we're passing a book in to edit the book, you're passing by reference. Objects pass by reference. That's just their nature. That's how they pass. The data passes by reference. Therefore, changing this book object should change it in two places, right? It should change it in two places. In a connected model, you actually don't, because of that passing by reference, if you were to update this book's properties, you would be doing the update. You would perform the update. You actually, in a connected model, don't have to call this save changes method. Again, all you'd have to do is update the book and it would update the database. But this is a disconnected model. Because of the disconnected model on these actions, you have to call save changes. And that will essentially run the update query, and get the data updated in the database. And you can kind of see here, the actual update, the update method is not necessary. Save changes is still necessary. Notice here they say in a connected model, you actually don't need to call the update. And here in a connected scenario, you just update the book and then you call save changes. This is the code that we wrote in our C# class because our desktop apps were in a connected state. Right, so the only difference here, again, is that in this disconnected world, we call update first. That's what you've been doing all semester, but now there's a little bit more of an explanation as to why we've been doing that. Makes sense. Two different models. A connected model, be it the desktop app, and a disconnected model being HTTP across the internets.
So the way we've been doing it is the right way to do it?
Yeah. You don't have to change anything about. You basically, in this disconnected model, you have to call these methods, and you have been calling these methods.
So then that helps against concurrency problems?
We're getting to how do you fix the concurrency problems. So how do you fix the concurrency problems? It's important to kind of take a step back and realize in the big picture, there's two ways that you can decide to solve this. Way number one is kind of just how it works out of the box. So this first way, if you say, hey, I'm going to handle my concurrency problems this first way, the scenario that I gave where two different people are updating the same record, the same row of information, that's called last in wins. Last in wins is the default. So again, user 1 updates the last name. User 2 updates after that. User 2 updates the street address and then overwrites the last name to the old last name. So that's kind of a problem. But that is, you could just say, you know what, the odds of this happening are kind of small, where two people are editing the same record at the same time, and I understand that it might lead to some corrupt data, and we just have to fix that. And that could be how you decide to solve it. That is kind of how it's working right now on all of our apps. On all of the software that we've written so far, last in wins. That's the default. Okay. The other solution's a fun little name. They call it optimistic concurrency. Okay. Optimistic concurrency is a fancy word for basically it doesn't allow the second update to happen. The first user, their update applies, and the second user gets an error message. And the error message would say, the information you're trying to update has changed. Please refresh and try again. Right? So optimistic concurrency is not the default. You have to code for it. And how do you code for it? Well, and Vinny came across a little bit of book code earlier, and he's like, I saw that in the book, I put it in, but I'm not sure what it does. Right? So Vinny has seen this code, I know this much. And this is what this is. So let's say you're going to edit the books and you want to add optimistic concurrency, right? So essentially you're throwing an error message if two people are trying to edit the same book. It's first in wins in that scenario, right? The default is last in wins, but in optimistic concurrency, the first one wins. Their update applies, the second user gets an error message. Those are the only two scenarios. Either you let the first one in or you let the second one in. It's really simple. They just got a bunch of fancy terms around it. Right? You let the first one in, you let the second one in. You know, by default, you let the second one in. You know, And that's really not the best because it can lead to some corrupt data. So you might consider first in wins and then giving the second one an error message. Give the second guy an error message. Tell him to refresh the data, right? Refresh the page and then run the update again. They do that with an attribute, like again, so you're adding optimistic concurrency. High level, we're adding this thing called row version. You could do it with an attribute, or you can do it with this Fluent API. It's going to be easier to just say, okay, this timestamp attribute, again, when an update would occur, remember in JavaScript, every operation we just said, hey, update the timestamp, update. When's the last operation done? Right? That kind of thing. That's all you're doing here. You have a timestamp, and it's going to look at that timestamp and see if the, let me see if I can get this right, if the record, if they retrieve the record before an edit was made, right? If they retrieved a record before an edit was made, that's going to throw the exception, right? Because they retrieved a record, an edit was made, and then they're not going to allow them to update that record. Instead, refresh the data. Yeah.
Why is it stored in a byte array?
That's...
First time I've ever seen us use a byte.
Yes, they do talk about that. For a row version to work, it must be declared as a byte array type. Well, there you go. I don't know, but it says it's a must.
Because those are tiny, right? Those store like little to nothing.
Bytes are, an array of bytes can be as many as you need, right? It could be many bytes, but you're right, a byte is literally 8 bits. It's the smallest type that we have, but it is an array of them, so I guess it can grow as big as it needs to be. Okay, step 1, you add this property to the entity that you want to enable. And then what? And then you can start using try catches, because what happens here, just by adding this, that's enabling this thing called optimistic concurrency on our books. Okay, and then the database throws an exception, right? When user 2 goes to update their record and he can't do it, the database throws an exception. We actually haven't, I don't think we haven't handled exceptions yet, right? So you can get into the weeds here, and really, this is on updating the book, but kind of the big picture is we're trying to save changes and we're catching a concurrency exception, right? And then we give the user some sort of error message. You don't have to tell them exactly what the book tells them. You could just tell them your update didn't work, run the code again, right? You don't have to implement that logic in the catch block, but it needs to be caught so it doesn't crash your exception. And that's the high level, right? That's the high level version of how to implement what's called optimistic concurrency. Fun words, but they're really not that too bad. Yep.
So what's going on in that catch? Like, what is that code?
Oh, you would ask me that. It's giving an error message. It's telling the user, hey, you tried to update this user, unable to save, this book was deleted by another user, whatever it may be. It's an error message. And there's an exception object called EX. EX, because of this type, has a property called entries, and you can get database values. So you're trying to update this data from the database, and you can't. Actually, there's a little bit there, and if that didn't look like, oh, that's not so bad, wait, there's more. Because this was like a delete, right? If, hey, that data's not there anymore, someone deleted the record that you're trying to update. This else block is the edit version, right? So, hey, someone else edited the data.
So correct me if I'm wrong, but I feel like I've seen this before. Like, I've been on like a forum, and there'll be like a user that like posts something, and let's say maybe like two moderators go to remove the same post by the user.
Yep.
If they click on it at the same time, one removes it first. The other one's going to get an error saying like this post has already been removed.
Which is this right here.
Okay.
Right here. Now, remember this? Model state, add model error, right? When we were making our own validation errors, right? So that's kind of, you know what that does.
So that's called concurrency?
Concurrency conflicts.
Gotcha.
Concurrency conflicts is when two people are trying to make edits to the same record, literally the same record, like you're saying, the same post.
Yeah.
One person's trying to edit it, the other one's trying to delete it. They delete it first. This guy can't edit something that's deleted, right? Concurrency conflicts is exactly that. Okay, so that's that idea behind concurrency. Ryan, when I said, oh yeah, I knew you were going to ask me that, like, at a high level, you're going into the data out of the database, and if the data is deleted, you're saying, hey, the book was deleted. Otherwise, it was modified by another user. This else block is hey, the data has since been modified. Okay, we are, casting this into a book, right? So we're able to say, hey, the book's title is a current value of, blah. It's trying to give a very descriptive error message back to the user. And I guess the last piece to mention is when you have an edit view, you need to include, just like when you're editing the book ID, like if you leave that book ID off of that, then it's not going to know what book to edit, right? So you need to include that. You also need to include that row version, because that's not going to be on your edit form. You're not going to include the row version on the form, but you need that from the controller into that view so that when it goes to do this edit operation, it has the data it needs to work. So it's kind of like that book ID. We had this in the past kind of stored in a hidden field, and you need that row version also stored in a hidden field for this. So the problem is a concurrency conflict, right? And how you solve it is with optimistic concurrency. That's the name of what we're doing here. We're putting optimistic concurrency is solved in this world by adding this attribute, adding this timestamp, try catch block, and this little hidden field in the view.
Something else I'm gonna forget to put in there.
Yeah, I'm sure there's something. Okay. Now, that's kind of a couple concepts towards the end of the chapter. There are a couple more, and here is here's one. Again, it's kind of nice to reference what we did last semester. Last semester, when it came to our database logic, we had a file. I think we called it database.js, right? All of our database logic was stored in that database.js file. That file was completely separate from the server logic, right? We would call on that file to get data and update data and do things like that. Right now, we don't have that file, okay? in the development world, right, it's a pretty simple name, data access layer. Data access layer. And so this data access layer is that exactly that. It's the layer of the application that you're working with the data. Right now, that is essentially built into our controller. We don't have a separate data access layer. Our data access layer, our update operations, our add operations, it's all right in our controllers. The controller is the middle tier. It's supposed to, you could put business logic in there, like if statements and, but think about what a controller does. A controller is where the request comes into from the client. A controller is supposed to use the data access layer to get the data, and then it sends some data back to the view. Right? But that is supposed to be like C# in the middle, but it's not really supposed to have our data access in it directly. Okay, so all this data access layer, this data access class, is very simply, this is our database.js file. And we're going to put our operations of working with the database inside of this class. Okay? And if it was that simple, that would be great. If it was that simple, that would be great. Of course, it's not quite that simple. If I was just, okay, take the logic out of your controller, put it in a C# class. Here we go. Here's our C# class called book data. This book data needs to take a context. We know how to pass a context into a constructor. And then, hey, we got a method called get and we got a method called list. So go ahead and construct a book data object. Go ahead and construct a book data object, pass it the context, and then now we can just call the data access class, we can call the list method and get all of our data back. It's exactly what we did in JavaScript. By the way, another term that you're going to hear a lot is encapsulating your code. And that's what we're doing here. We're encapsulating our code, in other words, putting it in the right container, right? We're taking our database access code and encapsulating it, putting it in the right container of a data access layer class, right? When I was a kid, they would do time capsules of the 90s, right? They would on Nickelodeon, and they would encapsulate artifacts of the 90s in this capsule and bury it 100 feet deep. You know what I'm talking about? That's encapsulation. It's encoding. You're putting all the right code in the right container. That's encapsulation. So you're going to hear it. We're encapsulating our data access layer. Vinny.
No, it says that doing this encapsulation allows you to change from like the EF core to another framework.
Yeah.
Are we going to be doing that?
No.
They're just going to be using entity framework?
Yeah, because you could use the same data access class, potentially, I don't know, in another C# world.
Gotcha.
You know, because at the end of the day, there's still C# methods you're going to have to call. It would be nice if we could call this from the JavaScript world. But literally to call this method right here, this list method, I mean, these methods we're writing are C#. You know. Okay, so step one, understanding what a data access class is, understanding we've done it before, and kind of how it's done in C#. Again, just looking here, it's done by making a C# class, putting a couple methods in that class, and those methods ultimately return data, right? Using, in this case, here's a link query, right? A find method. Learn something new. These methods, well, you take a look at their input parameters. We've got, this one takes an int, this one takes nothing. I didn't know that as an input parameter, you could actually accept a link query. And why would you want to do that? Well, we could then, in our get method, pass a link query to it to say, okay, get a book where the book ID is greater than 50. Right? So our methods can accept link queries, kind of interesting. Understand the power, there's a little power there, right? Because link's pretty powerful. And that's where this goes, right? The next step, the next iteration, was okay, data access class, it's got some methods in it to get the data. Okay, these methods can actually be flexible and accept link queries to allow the developer to write a little link and get data in all sorts of ways. So looking at this, kind of interesting, our list, this actually takes two link expressions, a where and an order by. Now, this is interesting because this list, if you look at this where clause, where, if you think about the link that we write in our where, all of the where clauses basically evaluate down to true or false, right? So this list method would allow us to write a link query with the where clause, where the book price is greater than 10, true or false. So the syntax here, with this expression, function, where we are comparing books in this where clause, and this where clause, the book expression is either going to be true or false. Each book is either going to be over $10 or under $10. The order by, though, if you think about what an order by does, it's going to have to compare objects, right? And so, you're either going to return an object if it's greater than, or return a different object if it's less than. Kind of think of like the sorting operation that an order would have to do. Obviously this is a sorting operation. Remember the old iComparable interface in C#? We had to implement iComparable, that kind of thing. The point is you're sorting objects, and so the return data type here is a type of object. So your order by clause is returning an object, your where clause is returning bool, they're both comparing books. That makes sense. And then that allows this. That allows our list method to pass in two arguments. The first argument is the where clause, where the book price is less than $10, and an order by, ordering by the book.title. Now, if you wanted to call the whereby clause first, remember you can always pass by named parameters. If you remember that in the C# class, if you know the name of the parameter, in this case the where and the order by, you know the name, you can actually call these out of order. Because again, if you wanted to call the order by first, you could put order by first here, colon, and then do the order by first, and then the where clause. Calling by name, that's the advantage of calling by name. It's also a little bit more readable, right? This is a little bit more readable. So you can actually change the order in which you pass your arguments when you pass by name. But I guess the advantage on this particular line of code is just a little bit more readable than this one, right? Because we just wrote the method, we know that this is a where clause and we know this is an order by clause, but that's not very readable. True or false, you guys remember these passing by name at all? Yes, no, a little bit? Looks familiar. Like you got to name num1 and num2. You could say num2 is a 5 and comma num1 is a 3, even though they're not in that order.
I remember that.
Right? You can pass them out of order.
So
And
the first example has to be passed that way because we're not doing a name.
because we didn't name it. Yeah, the second one, you're saying, okay, this goes into this where parameter, right? So this is the data type right here, and this is the identifier. This is the data type, this is the identifier. So if you know the identifier, you could put the identifier colon, and that's going to put that data into that variable, which allows me to, if I wanted to, I can kind of come up here and cut that and paste it. I'm not editing this, but that's the idea. Okay. If that were as complicated as it got, that'd be great, but it doesn't. It gets a little bit more complicated. And so here we go. Well, what is this good for? If I write this link query this way, notice how it's good for books, right? So I had to write a class called book data, and I'd have to do that for all of my types, right? I have to do another one for authors. I'd have to do another one for genres. I'd have to do another one for movies. You know, this class is not the most reusable that it could be because it only works with books. Enter a more generic query options, right? Again, going back into C#, we didn't spend a lot of time on generics. The convention on generics, what is a generic? A generic is a class, again, if you've used a list, you know that a list can take in any data type. That is a generic. It's like, I don't know what this type is, but I'll accept anything. I'll accept any type, right? The convention for defining a generic, right? The convention for defining a generic is to put the angle brackets with the letter capital letter T. Okay, so when you're creating the list class, you can go into the list class and see a list of T. Vinny, I cut you off.
I was just saying, no, I cut you off. I was just saying that T means anything.
It means it accepts any type.
Gotcha.
It is a convention to be the capital T. Okay, doesn't have to be the letter T. It could be any other letter. Okay, one of my favorite programming jokes is a cup of type T. Cup of tea. Ha ha ha, cup of tea.
You know, I don't know if you remember.
You know, as geeky as that is.
Before the semester started, you had linked a bunch of videos in Discord, like to refamiliarize ourselves with C#. And it's a guy and a girl, and the girl actually.
I know. I stole it from him.
Oh, really?
I stole it from
I feel like
him.
you gotta get dad with kids to make that joke.
Yeah.
One thing in the next paycheck, I'm ordering that cup. No one's gonna understand about being.
I don't know how I don't have it. Here's the thing. I need a big cup though. I drink a lot of coffee, so I want a big. Well, I drink a lot of tea.
True.
Oh my gosh.
There you go.
Okay. What's the benefit of this? Okay, so what are we doing? We're making a class that works with more than just books. We can say, hey, this query class works with books, it works with authors, it works with different things. You can see it takes some different properties. These properties are link queries, like an order by property that returns a link query, a where. Okay, there's also a page number and page size. Again, this is going to allow us to make a generic class called query options that takes a generic type T, which allows it to take in books, allows it to take in authors, and when here, I just wanted to jump forward and show, how you would use this class, right? So here we have this query option type of book, that's that generic type, right? The type T, called options. And notice we're storing a beginning of a query in an iQueryable interface variable called query. We loop through our options and kind of update the query. If there's a where clause, update our query with that where clause, update our query with that order by, update that query with that page by option. Page by option is a little bit different than the other ones because they made that an extension method. There is no page by default. That's why I jumped over this one. This is an extension method. Remember, again, not that we did a whole lot of extension methods, but all an extension method is a new method for a class defined outside of the class. So in this case, we're extending the iQueryable with this first argument right here. We are extending the iQueryable interface, and we're adding this method to it called pageBy. And so that enables this feature right here. Here we go, code that uses the method. So finally, here we can get into var books equals data list new query options of book. You throw in an includes, an order by, a page number, and a page size. And this is going to be one that we gotta do this, right? And I'm sure just by looking at this code, you're going, okay, I kind of get it, but I need to do it. And I would agree with that. The last page of this chapter, okay, deals with this iRepository interface. And here's what I'm going to say about that. First paragraph. One benefit of this pattern is that it makes it easier to automate testing as shown in chapter 14. We're in chapter 12. I think I'm going to focus on this because, again, it's complex and we're not using it until chapter 14. So if we get to chapter 14, when we cover chapter 14, we'll dive a little bit deeper on this iRepository pattern. Again, one benefit of this pattern is that it makes it easier to automate testing as shown in chapter 14. I think that's a bridge we'll cross when we get there. This chapter is long enough without that. And so we'll cross that bridge when we get there.
Yeah, they definitely could have made this 2 chapters. I feel.
Yeah. Or more.
Or more.
Or more. All right. Now, what we'll do is we will do the exercise in the back of chapter 12 together to exercise 12.1 that says review the data layer of an app and improve it. Okay, so we're going to open up the chapter 12 EX1 class schedule in the starter directory. So documents, student download, EX starts, chapter 12 class schedule. And let me get sharing my screen because I'm sure I'm not. Okay, class schedule. Open the model, domain models. Another folder called data layer, another folder called configuration. Cool. And so let's look at the code in the 3 classes. We have a class with a class ID, a class number, a military time, looks like a relationship to teacher, and a relationship to day. So a class has 1 teacher, and a class looks like it runs on 1 day. Let's look at day. What is day? Day ID, day name. A day can have many classes. So this was kind of a new syntax, right? Initialize the navigation property, right? New hash set, so each class has to be unique inside of our collection. teacher can have many classes, right? So a class can have one teacher and one day. A day can have many classes, and a teacher can have many classes. So that's kind of the schema for our database. Kind of curious, it does look like we have a migration, and so let's kind of see that. And it does have some data to insert. So I'm not sure if it tells us. Yeah, it does. Okay, so I'm jumping ahead. Open the models configuration folder and review the code in there in the 3 configuration files. So models configuration. So class config has all of our seed data. Day config, Monday through Sunday. Teacher ID. Now if we open our context, that's our snapshot. Here's our context. Context just applies these new configs here. Now it's pretty interesting to me, like, you can give it the namespace models, and it's able to find day config. That's in a subfolder, right? You didn't actually have to point it in the subfolder. It's able to find the type. Does that make sense to you guys? Like, a lot of times you got to get it actually to the folder, but it's because it's a child folder. The fact that we're organizing our models here in these different subfolders.
We don't have to actually like get to the data layer subfolder.
Bingo. Bingo. It can just traverse it and find it. Okay, so what have we looked at? We've looked at our model classes, right? So why is it called domain models? You know, a lot of times that's the problem domain, right? What problem are you solving? What classes are solving the problem domain? So the domain model. Right, we haven't looked at anything in data layer yet, but then this configuration is just our seed data, but our data layer actually does have our context file in it now, and here we're just seeding our data, just like on our other context files. Of course, there's that iRepository. I said, hey, we'll worry about that when we get there, of course. They throw it at us right away. Query options, this is that class. I mean, this is pretty much exactly what the book had for this query options class. But they don't have us looking at query options yet. Let's come back to that. Okay, review the migration file. Open the migrations folder and review the code in the initial migration file. So here's initial. We should just be able to run update database, and it's gonna give us all the seed data. Note how the migration file determines the primary and foreign keys based on how the properties in the domain model are coded. And it's all done by convention. Create the database, open the package manager console, enter the update database command. Run the app and review the data it displays for classes and teachers. Okay, so this is the class schedule on the home page. Looks like we've got some filtering here by routes, right? So passing a day ID into the route is going to help us apply a filter. Each one of these is posting data back. Show all teachers just has teacher in a table. Okay, nothing too crazy.
Is your teacher missing a first name? Show all yeah.
Aristotle is just Aristotle.
He's a one name now.
Maybe his name is blank.
Okay, the next steps on page 499 is to show the cascading delete. Again, we kind of covered this theory, what is a cascading delete, and it's the default, but the idea is this: you got a teacher, teachers added, sorting by last name, add a class, add a teacher to that class. Guess it'll run on Saturday. Class number between 100 and 500. Oh, right. So we'll call it 1400. Let's add me to two classes. Delete the teacher, and it should have deleted the classes, and it did. Right, so that's the cascading delete, which is kind of a default behavior, and obviously that's risky, right? If you delete something, you might unintentionally delete a bunch of other things. So most databases don't, kind of do that out of the box, but this one kind of has some risky behavior. So restrict the cascading delete behavior. So let's close that down. In the models configuration, class config, add code to change the delete behavior for the teacher foreign key to restrict. So we'll use that kind of code example. Where this is a class of a class has a, again, let's go back to the domain models. Has a teacher, and a teacher has many classes. So it's a one-to-many relationship. So let's go here, class config. So the class has one teacher, and then from the teacher can have the teacher with many Teacher has many T dot classes. Did not mean to put a dot there. So you kind of define it both ways, right? The class has one teacher, and the teacher has many classes. And this is where, again, I'm just referencing the code on page 467. We'll say on delete, this is changing the delete behavior to restrict. Sir?
So that just doesn't allow you to delete a teacher?
If the teacher has classes, you have to delete the classes first, and then you can delete the teacher. Make sense? And what's going to happen here is if you try and delete the teacher that has classes, it'll throw an exception. In which case you need to try catch block to handle the exception. Let's go ahead and, since we've kind of changed this option, we'll run a migration. So we'll add migration restrict cascading deletes. You can kind of see here it's now got some language in here on delete, restrict. And if we test it again, I guess we need to apply that, right? We need to update database. Back here, update database. Done. Now we can test it. There I am.
Do they have logic on this for like if you try to create the same class twice at the same time?
No, I don't think so. I didn't see it.
So so if you're trying to delete a class now, it's not going to delete the teacher.
If you delete the teacher, it will break. In other words, so before we deleted the teacher, it also deleted the classes.
Right.
Right. So now if we go to delete the teacher,
Okay, so it breaks.
breaks. So we're not allowing cascading deletes, which is funny because we just introduced this error and we're happy about it. But it's doing what we intended. Okay, next steps is like, hey, go ahead and run the app again and edit the class. So here's this, and change the teacher so that now I am no longer teaching any of the classes. And now go back to show all teachers, and it should let you delete. There you go. Okay, next step. We're on step 22, page 499. Change how the list of classes is ordered. Open the home controller and review the code for its index. We'll close all the files. Home controller, index method, takes an ID. Note that the classes are ordered by day on first load and ordered by time when filtering by day. So order by day ID. If ID is 0, that's on the first load. So you're ordering by the day, which you saw. I saw that it was like Monday, Tuesday, Wednesday, Thursday, Friday. And ordered by time. So here, order by the time. Otherwise. Says run the app. So here's our ascending order by day. When it displays all classes, note it doesn't display the classes for Monday in ascending order by time. So here's Monday classes and Monday classes. Well, there's 3 of them and they're going in descending order. Then click on the filter link for Monday and notice it does order them by time. In the models data layer folder, open the query options class. Note that this version is shorter than the query options class presented in the chapter. That's because it doesn't provide for paging. So in the chapter, query options on page 493, it actually introduces a static class called query extension that gives you the paging. And again, there's no page size property here. There's an order by property. There's a where property. There's no page number or page size. So there's some things missing from it's on page 493 and it's missing from this class. Is what they're pointing out. Add a new property named then order by that works like the order by property. Add a new read-only property that has property named has then order by. So then order by and another property called has then order by. It works like the has order by property. Okay. So here's order by. We need to add a then order by. Okay, so that was step 25. Add a new property named then order by that works like the order by property. Add a new read-only property that named has then order by. So down here, there's the read-only properties. That works like the has order by. public bool has then order by Step 27, open the repository class and find the list method. iRepository. That's the interface. This is the class. Repository class implements iRepository. Update the code that handles the ordering so it uses the then order by property. Like this. If options has order by. Okay, step 28, in the home controller, update the index action method to use the new property to sort by time as well as day on the first load. So let's see how this looks. Home controller on first load, order by CID. We need to use class options. Then order by C dot, what are we doing? Time? Military time? Pretty cool. Repeat step 23. The class time should be in ascending order on both pages. Step 23 is just launch it and look at it. Monday, ascending, ascending, ascending. We just added a then by clause, but we kind of did it in an abstract way by adding it to this repository pattern, adding it to the query options class first. Does anyone need to see any chunk of this? Good? Good. We are on step 30. Add an overload for the get method in the repository class. So here's a get method in our repository class. Open the class controller and review the private helper method named get class. Open the class controller and review the private helper method. Here's get class, private helper method, get class. Note that it uses a list method of repository class. Right here. So this classes, if we look what classes are type of repository class. You see how we can use these link queries with classes, teachers, days. Then it uses link first or default method to retrieve the item. Classes.list, class options, list first or default. So get class returns. What was once very clean code, like you knew exactly, very direct in querying that database. They've abstracted it a couple of layers. So you got to kind of dig through the tunnel to get to what's happening. In the models data layer folder, open the iRepository T interface right here and add a second get method that accepts query options T. Now, that's how I interpret that. Oh, that accepts, I'm sorry. So it returns type T, but it also accepts query options T. Stop this from running. Open the repository T class and implement the new get method. So this repository class will need to implement this new method. So I'm going to show potential fixes, implement the interface, which will bring in that method right here. To do that, you can copy the code from the repository's list method that builds a query leaving out the code for ordering the list. Then you can return a single object by calling first or default method instead of a list method. So copy the code from the repository's list method that builds a query, leaving out the code for ordering the list. So again, we're going to the list method here, which is right here. Just going to copy the whole thing because it says leave some of it out. Paste it here. Leaving out the code for ordering the list. there's no, here's your ordering. Then you can return a single object by calling first or default instead of the list. Okay, in the class controller, update the get class method so it uses the new get method. So instead of list, class options, run the app and test it. It should work the same as before. All good there, all good there. Okay, that is the end of the exercise. Pretty comfortable with all that personally. Minus, I will be honest, that repository class is still a work in progress for me. Starts with this interface, then we have this class. I understand kind of the theory that instead of building all these data access classes, that you're writing these methods, and these methods accept link arguments, that we're kind of abstracting that a layer. But I think I'm just gonna have to work with this a little bit more. This repository pattern. Might watch a YouTube video or two on it and see if I can't get a little bit more comfortable with that myself, because everything's good in this chapter for me personally until I hit that. I'm a little uncomfortable with that, but that's okay. That's how you learn.